In this video, we'll learn about vSphere high availability and how it can be used to protect our virtual machines from an ESXi host failure. So the purpose of high availability is to protect our virtual machines from failures, but it does not provide 100% uptime. HA is going to involve virtual machines rebooting. It's going to involve virtual machines potentially being down for a little while if something like an ESXi host failure occurs. There is going to be an outage associated with that. What HA does is essentially, if an ESXi host fails, all of the virtual machines running on that host will fail. But after the fact, after that failure occurs, high availability will start rebooting those virtual machines on different hosts within that cluster. You can protect your virtual machines from failures at the host level, or you can even protect your virtual machines from virtual machine level failures with high availability. So it can actually monitor the status of VMware tools in your virtual machines. And if VMware tools stops responding, that virtual machine can be rebooted right on the same host. So HA can protect you from failures at either the host or virtual machine level. And we can use things like admission control to ensure that we have enough spare capacity, right? So for example, if you have a cluster of 4 hosts and one of those hosts fails, we need to make sure that the surviving hosts have enough spare memory and CPU capacity to acceptably run all of the virtual machines that used to be running on that host that has now failed. That's what we'll use admission control for, is to guarantee that we have spare available capacity. And one final point about HA. It does not utilize vMotion. Don't confuse HA with DRS or with vMotion. Right? High availability does not utilize vMotion in any way, because vMotion is used for running virtual machines, virtual machines that are up. With high availability, if a host fails, my virtual machines are down. So let's take a look at how high availability works. Here you can see I have a VM called VM1, and my VM is running on host ESXi01. And so I've got this VM running, and right now everything is fine. Right? My VM's working, it's running on host 1, and my VM also has access to all of its files that are down here on shared storage. Right? And by the way, shared storage is required for HA. So I have to have some sort of shared storage system that all of my hosts in the cluster have access to. So I've got shared storage, I've got VM1 running on ESXi01. And then something happens, something goes wrong, and ESXi01 fails. Right? So now my host that the VM1 was running on is down. And my VM can't run if the host is down. So VM1 fails right along with that host. So there's going to be some downtime for this virtual machine and every other VM that was running on that host. And what's going to happen now is the virtual machine's files are still intact. Right? The VM's running state or live state may have been affected, but there's still a set of files for this virtual machine that are intact that exist on shared storage. And those files can be used to now boot up another instance of that virtual machine on some other ESXi host. And that's how high availability works. When host 1 fails, host 2 or 3 or 4, one of them is going to be a master host, that host is going to recognize that, hey, host 1 is down. Let's take all the VMs that were running on that host, we'll leverage their files, which are still intact, and we'll start booting up all those VMs on the surviving hosts within that cluster. So now we're just going to take a very brief look at the architecture of high availability at a pretty high level here. And here we see VM kernel ports running on every host in my cluster. Right? And those VM kernel ports are marked for management traffic. And so what high availability is going to do is once we go ahead and we create our cluster, right, in vCenter, we go ahead and enable high availability on this cluster. Then at that point, what will happen is once high availability is enabled, an election will take place. And one of these hosts in the cluster will take on the role of master. Every other host in that cluster will take on the role of slave. The other thing that'll happen when we enable high availability is the fault domain manager, or FDM, will start running on each of these hosts, right? And the fault domain manager is basically responsible for these hosts communicating with each other, right? So the master host will be constantly sending heartbeats to all of the slaves. All of the slaves will constantly be sending heartbeats to the master, right? And so basically this allows the master to know, hey, if any of the slaves are down, the master will know. Or if the master itself goes down, all of the slaves will know. Right? Master sends heartbeats to the slaves. Slaves send heartbeats to the master. And this allows our cluster to detect failures. Right? So if we have a slave host that all of a sudden, goes down, it's going to stop sending heartbeats to the master. The master can determine that, and it'll do a couple of tricks to verify that that's actually the case, that the host is truly down, at which point those VMs that are affected can start booting up on other hosts. Okay, so from the perspective of the VMware Certified Associate exam, what you need to know is that high availability provides a reliability mechanism, right? If a host fails, those VMs are going to restart on other ESXi hosts, but there's going to be some downtime associated with that. And really the ideal way to configure this is to enable both high availability and DRS on your cluster. HA does not use vMotion though. And we took a little brief look at the architecture, how the master sends heartbeats to the slaves send heartbeats to the master, and that's how we determine if a host has failed. And the component that actually runs in the host that handles all of this heart beating and the communication between hosts, it's called the fault